As I mentioned in a previous module, a pump is a device to impart pressure energy to water by converting kinetic energy, that is water in motion, to pressure energy. Now this pump is normally referred to as a prime mover. Now this prime mover will have a certain maximum output, and this will be quoted in watts, and therefore the pump is limited to this output. Now when the pump is running at any given speed, this energy can be made to move either a lot of water at low velocity or a small amount of water at a high velocity. Now in both cases the energy requirements will be the same. Now what happens if no water is flowing? Well, the energy will be stored in the pump in the form of pressure energy, and the pressure gauge will be at its highest. So the pressure gauge, if there's no water flowing, is the highest. Now as you open the delivery and let water flow, the pressure will drop as this pressure energy is converted to velocity energy at the nozzle. So as you can see, the pump converts velocity energy to pressure energy, and then this is released back to velocity energy when water flows back through the hoses. Now as I mentioned earlier, pumps are rated in watts, and this again is the power available at the pump. Now there's two powers you need to be aware of, and these are brake power and water power. Now brake power is the actual output of the pump and is usually measured in kilowatts, so it's in kilowatts. Whereas water power is the actual ability of the pump to work, and this can be determined by this formula here. Water power equals 100 times L times P divided by 60, where W is the water power, usually in kilowatts, L is the flow in litres per minute, and P is the pressure in bars. Let's do some examples using these formulas then. I want you to determine the water power of a pump which is delivering 3,300 litres at 5 bar pressure. If you put these in the formula, as you can see here, that comes out at 27,500 watts. Let's do another example using this formula. Determine the water power of a pump which is delivering 2,600 litres at 3.5 bar. If you put these in the formula, the water power comes out at 15,167 watts. Now that is the water power. Now what's another important factor with pumps is how efficient the pump is. In other words, how much of the brake power is converted to water power, and this is the formula to determine the efficiency of a pump. The efficiency is the water power divided by the brake power times 100. So let's do an example. Determine the efficiency of a pump with an input, that's the brake power, of 30 kilowatts, and it's pumping 2,300 litres a minute at 5.6 bar. What you have to do first of all is determine the water power available, and this is the formula here. If you put in known variables in there, you get a water power of 21,467 watts. Now you've got that, you go to the efficiency formula, which is this one. The efficiency equals the water power divided by the brake power times 100. Put the numbers in, the known variables in, you get an efficiency of 71.6%. Let's do another example. Determine the efficiency of a pump with an input, that's brake power, of 49 kilowatts, and it's pumping 4,100 litres a minute at 6.3 bar. Don't forget, first of all, you've got to determine the water power available using the formula here, water power. Put in the known variables, you get a water power of 43,050 watts. Now we need to determine the efficiency using the following formula. Efficiency equals water power divided by brake power times 100. Put the known variables in. This time you get an efficiency of 87.9%. Let's do one more example. A pump with a brake power of 36 kilowatts and an efficiency of 75% discharges 2,750 litres a minute at a pressure which is 1.2 bar higher than the pressure of the 1,800 litres a minute discharged by a second pump having an efficiency of 68%. What is the brake power of the second pump?